Okay, hello again. These are the questions and answers on metals. So let's take a look at the first question. It says, which property do all metals have? Remember, when we say all metals conduct electricity. You can't choose any of the others. Which substance is a metal? Well, if it's a metal, will it conduct electricity solid? Yes, it's the only substance that conducts electricity as a solid. That would be a metal. Apart from graphite. So yes, it should be high. Electrical conductivity when molten, yes. A metal has free moving electrons, so it conducts electricity both as a solid and as a liquid or molten. Which compound is likely to be colored? Well, the one that is colored is the one that has transition metals. So which of these has transition metals? So that is A. A contains manganese, remember. Okay, M is a shiny silver metal. So first of all, we have 4 metals, aluminium, copper, mercury, nickel, and we're supposed to choose from them. Now, if he says it's a shiny silver metal, which one is not correct? Shiny silvery, aluminium is shiny silvery, mercury, nickel, but not copper. You should know that copper is not silvery, it is reddish brown. So, if we're talking about M is a shiny silvery metal, so B is wrong. It has a high melting point. Which of these choices does not have a high melting point? You should know that mercury is the only liquid metal. So if it's a liquid, that means its melting point will be lower than room temperature. So if we say it has a high melting point, then mercury is out of the question. So we're choosing between aluminium and nickel. Now he's saying many of its compounds are green. Now, which kind of elements have colored compounds? We said to be colored, to have colored compounds, it should be a transition metal. So the only choice we should choose is nickel, because aluminium is not a transition metal. Aluminium is in group 3, so its compounds would be white or colorless solutions. The table shows the reactions of 4 different metals with water. Remember, how vigorous the reaction is determines the reactivity. So, which of these is the most reactive? He says one reacts vigorously with cold water, the other one no reaction, one reacts very slowly, and the other one reacts violently with cold water. You should realize that if something reacts violently, this is more reactive than vigorously. So Z is more reactive than W. He wants from most or from least. Sometimes he says from most to least, and sometimes from least to most. This is from most reactive. So which one is the most reactive? Z. So my answer is C or D. Z reacts violently, and then W, and then which one? The one that reacts very slowly would be more reactive than the one that doesn't react at all. So W before X, so your answer is D. Steam is passed overheated magnesium to give compound X. So, first of all, we said when steam reacts with magnesium, it should give what? Steam with magnesium gives magnesium oxide. So, we're talking about magnesium oxide. And he's saying what is not a property of magnesium oxide. Now, if you look at all of this, magnesium oxide will have a molecular mass of 40. It is basic, it is a white solid, but it is not soluble in water. So the one that is not right is D. Okay. The diagram shows the properties of 4 substances. Which one could be magnesium? Okay, magnesium is a metal. So does a metal bend or break easily? Remember that we said metals are malleable and ductile, so they can bend. They don't break easily. So it bends. Does it react with dilute hydrochloric acid? Yes, magnesium is above hydrogen in the electrochemical series, so the answer is A. Reactions of 3 metals and their oxides are listed. What is the order of reactivity? Now he's saying from least to most. So which of these is the least reactive? Okay, let us talk about this. Now he's talking about reacts with cold water. Which ones are supposed to react with cold water? The ones that react with cold water are potassium, sodium, calcium from the reactivity series. Anything below that up to hydrogen will react only with steam. So when he says that Y reacts with cold water, that means that Y is way up there. like potassium, sodium, and calcium. So Y would be the most reactive. So I'm looking at A or B. Now, he's saying metal oxide that reacts with carbon. Okay, for a metal oxide to react with carbon, it has to be less reactive. It has to be a less reactive metal than carbon. That's why we put carbon and carbon monoxide in that list. Can you see carbon and carbon monoxide? Now, if something is below or less reactive than carbon, then the carbon will react with its oxide. So carbon plus zinc oxide will react. Carbon plus iron oxide will react. Carbon plus tin oxide will react. But if the metal is above carbon in the reactivity series, the carbon will be less reactive than the metal, so it cannot displace it from its oxide. So I cannot say carbon plus magnesium oxide. It won't work because carbon is less reactive and will not displace the magnesium. I cannot say carbon plus aluminium oxide because carbon is less reactive than aluminium and will not displace it. So if something does not react with carbon, its metal oxide does not react with carbon, that means it's above carbon. The one that reacts with carbon is below carbon. So that means that W is more reactive than X, and that means that X is the least reactive of these three. So that means that my answer is B. Okay, some properties of 4 elements are listed. So let us take a look at this. W melts, and he's saying, okay, he's saying which of these elements are metals. So let's choose which ones are metals. He's saying, okay, W melts at a very high temperature and forms an acidic oxide. Do metals form acidic oxide? No, metals form basic oxide. So number 1 is wrong. Okay, let's look at number 2. Number 2 says X has a high density and is easily drawn into wires. Well, does that apply to metals? Yes, we said metals are ductile, easily drawn into wires, so X would be a metal. Y acts as a catalyst and its oxide reacts with acids. Well, which ones in the periodic table act as catalysts? We said transition what? Transition metals act as catalysts, so anything that acts as a catalyst is probably a metal, and its oxide reacts with acids. That's true because oxides of metals are basic, so they will react with acids. So 3 is right. Now Z is a reddish brown solid used to make alloys. We know, can this be a metal or not? Yes, reddish brown solid could be copper, and copper is used to make alloys, so it also is a metal. So that means I have 2, 3, and 4 are all metals. Okay, which statements about alloys is not correct? So, not correct. So he's saying alloys are more expensive than the metals they are made of. Well, actually they could probably be less expensive. Alloys are mixtures of different metals. Yes. Alloys are not as strong as the metals. This is the one that is not correct, because we said alloys are actually stronger and harder than the metals they're made from. Okay, which diagram could represent the structure of an alloy? Remember that an alloy is basically metal with different sizes of atoms. So I'm not going to choose A. A is representing an ionic compound because A shows negative ions and positive ions. We don't want that. Metals, remember, metals have positive ions with negative electrons around them, which we indicate only by a negative, not by negative inside a circle. So which of these would be the alloys? D is actually the alloy, in which we have atoms in regular rows, but we have different sizes of atoms in between. Okay, he's saying nichrome is an alloy of the 2 transition elements nickel and chromium. The alloy is used as heating coil in electric fires and electric toasters. So which properties are important for these uses? I want it to be a heating coil. So should it have high melting point or low melting point? Well, heating coil means I want to heat it to very high temperatures without having it to melt. So it must have a high melting point. So I'm looking at A or B. Now, when it's an electric toaster, do I want it to be resistant to oxidation, that is reduction, or not? Yes, of course, I don't want it to corrode and affect my food, so the answer is A. Some properties of aluminium are listed. Which properties make the aluminium useful for what? Now he's talking about making the bodies of aircrafts. Which of these should I choose for bodies of aircraft? So the first one says it has mechanical strength. Do I need that for the body of an aircraft? Yes, I do, because we said aircrafts, when they go up in the atmosphere, they are subjected to high pressure, so we need aluminium because aluminium is strong and can withstand high pressure. Do I need it to conduct heat? Well, I don't need it to conduct heat here. An aircraft doesn't need something that conducts heat. It is resistant to corrosion. Yes, I would like it to be resistant to corrosion. It has a low density. Yes, we need it to have low density so that it is not too heavy. So my answer is actually 1, 3, and 4. Okay. The following statements are about alloys. So we're saying alloys are what? Compounds or mixtures? We said alloys are mixtures of metals. Now, alloys conduct electricity. Do you expect all alloys to conduct electricity or only some of them? Well, what is the definition of alloy? Alloy is a mixture of metals and other elements. So it should have at least one metal, and if it has a metal, it will conduct electricity. So all alloys conduct electricity. So my answer is C. Which types of steel are used in chemical plants and machinery? You have to refer to the uses. We've talked about what do we use each of these types of steel for. Remember, we said we make chemical plants from which type of steel? Stainless steel. And we said machinery is made from mild steel. So my answer is C. Which object is least likely to contain aluminium? Aluminium is light. So which one is something that I can't make out of aluminium? Well, it must be a hammer, because if the hammer is light, then it's useless. So we cannot make a hammer out of aluminium. Okay, which diagram shows common use of stainless steel? We said we use stainless steel to make what? To make cutlery. So that is what we have in A. The diagram shows a section of an overhead cable. Which statement explains why a particular substance is used? Now, the first statement says aluminium has low density and it is a good conductor of electricity. Well, actually that is correct. That is why we use it in overhead cables. Porcelain is a good conductor. Do you know what's porcelain? Porcelain is like ceramics. It's something that's actually an insulator. So it is a bad conductor of electricity, not a good conductor of electricity. Steel can rust in damp air. Well, that's not why we're using it actually in overhead cables. Remember, we said, if we say why do we use steel in overhead cables, we said this is just to make it stronger. Steel is more dense than aluminium. Well, yes, okay, steel is more dense than aluminium, but that's not why we're using it in overhead cables. So the correct statement would be the fact that aluminium has low density and is a good conductor of electricity, and that is why we use it in overhead power cables. Okay, a piece of equipment needs to be made from a metal that is low density, strong, resistant to corrosion. Which metal does all of this apply to? Aluminium. In native copper, the element occurs as the metal, not as a compound. So we're saying an element that does not react will be found native. Native means I can dig up and find some copper, for example. And this happens if the metal is not reactive. Now he's saying gold is below copper in the reactivity series. So is it more reactive or less reactive? No, gold is even less reactive than copper. So which can be deduced about gold? So if it is even less reactive than copper and I can dig up and find copper, can I dig up and find gold? Yes, it occurs native. So I'm looking at A or B. Now, would you expect gold to react with acid? We said anything below hydrogen in the reactivity series will not react with hydrogen. Copper is below hydrogen even if you don't know where gold is. So if he's saying that gold is below copper, then it is less reactive than copper. So no, it does not react with acid. So my answer is B. Okay. A test tube containing damp iron wool is inverted in water. After 3 days, the water level inside the test tube has risen. Which statement explains this rise? Now, when I have damp iron wool, that means I have pieces of iron with water in it, and it is in this inverted test tube, so it has around it air that contains oxygen. So that iron wall up there is subjected to both water and oxygen, so it will rust. Now when it rusts, it uses up oxygen from the air in the test tube, and that is why the water goes up the test tube to replace the oxygen that has been used in rusting. So which statement explains the rise? The fact that the iron oxide has been formed, that's why the water goes up. Iron is a metal that rusts in the presence of oxygen and water. Mild steel is used for what? Where is mild steel? We said we use mild steel for what? Car bodies or cutlery? We use mild steel for car bodies, so we're looking at A or B. And is prevented from rusting by, so if we have car bodies, what do we do to it to rust it, to prevent rusting? We paint it. So this is by painting. Stainless steel does not rust. It is produced by mixing. We said iron with another metal because it's an alloy, and we said alloys are mixtures, so my answer is B. Which row describes how the metals are used? Okay, when we use mixed with zinc to form brass, which one is mixed with zinc to form brass? We said brass is made up of what? Zinc and copper, so my answer is C or D. Which one did we say is used to galvanize iron? Zinc, so the answer is D. Information about nitrates and carbonates of two metals are shown. Okay, we've talked about thermal decomposition of nitrates and thermal decomposition of carbonates. So first of all, let us look at this. If he's saying that the compounds are all white solids, so nitrates, carbonates of both Q and R are white solids, that means I cannot have a transition metal. So right away C is off the choices because it says R is copper. No, R is not copper, because if it was copper nitrate or copper carbonate, it will not be a white solid, it will be blue or green. Okay, solubilities, let's keep solubilities aside for now. Effect of heat. Now, we said, remember, when we're talking about nitrates, so let us talk about nitrates of Q or nitrate of R. If we're talking about heating nitrates, we said nitrates of group 1 will give nitrite plus oxygen, while nitrates of any other group will give what? Will give oxide plus nitrogen dioxide plus oxygen. So if he says nitrate of Q gives only a colorless gas that relights glowing flame, that means it gives only oxygen as a gas, then Q must be from group 1. So Q, we've already cancelled C. So Q is not calcium or magnesium. It has to be group 1. So actually my answer must be D. So according to D, Q is sodium. Yes, sodium nitrate or nitrates of sodium will give only oxygen when heated. And actually carbonates of sodium, we said carbonates of group 1 are thermally stable. They do not break down by heat, so that is correct. There is no reaction when you heat carbonate of Q. And if we say R is calcium, well, R could be calcium because nitrates of any other group will release brown gas, which is nitrogen dioxide when heated. And carbonates of R, if R is calcium, yes, a carbonate of R will break down to give carbon dioxide, which turns lime water milky, so my answer is definitely D. Okay. 4 iron nails have different metals wrapped around them. The nails were placed in an open dish filled with water and left for a week. Which iron nail has no protection against rusting? Okay. Remember, when we were saying we need to protect iron from rusting, what are the things that we said we could do? Well, we said painting, coating with oil or grease, and we said things like galvanizing or sacrificial protection. We said if we wrap the iron in a metal that is more reactive than iron, then it is that metal that will react instead of the iron. So when we wrap it in aluminium or zinc or magnesium, all of these are more reactive than iron. So it is just like sacrificial protection. The more reactive metal will be the one that loses electrons and becomes oxidized instead of the iron. But when we wrap it with copper, copper is less reactive than iron. So actually it will be the iron that will react and rust. So it is B that does not have any protection against rusting. Okay, to have protection, it has to be connected or covered with a more reactive metal, so that the more reactive metal will react instead of the iron. Okay, now which physical property is used to distinguish between metals and non-metals? And he's talking about something that is possessed by all metals but only one non-metal. What properties he's talking about? He's talking about conduction of electricity. Remember, all metals conduct electricity, and only graphite, which is a non-metal, also conducts electricity. Okay, the table gives melting point, boiling point, electrical properties, and so on. He's saying which two substances could be metals. The first thing you look at, for it to be a metal, it must conduct electricity as a solid, and of course have high melting point and boiling point. So just looking at it, the only two that conduct electricity as a solid are C and F. These have to be metals. Okay, explain zinc alloy. What do we mean by zinc alloy? Well, we said alloys are mixtures of metals, so here it's a mixture of zinc and other elements. Making alloys is still a major use of zinc. State one other large-scale use of zinc. What was the other large-scale use of zinc? Galvanizing of iron to prevent corrosion. Define the term steel. What did we say is steel? Steel is an alloy of iron formed by mixing iron and carbon. Okay, group 1 metals show trends in both physical and chemical properties. So if you remember from group 1, when we were talking about group 1 in the chapter on periodic table, how do their melting points vary down the group? Remember that in group 1, as we go down, reactivity increases, melting point decreases. So as we go down, the melting point decreases. Which element in the group has the highest density? Well, if we're talking about density, then it's the same as reactivity. Going down to the group, higher reactivity, higher density. So the one that has the highest density is the one at the bottom. Remember that we said at the bottom of group 1 there is something called francium. You totally ignore it as if it is not there. If you put francium, he will give it to you also, but we ignore it because francium is actually something that has different characteristics because it's radioactive, so it's slightly different from the rest of the members of group 1. Okay, all group 1 metals react with cold water, and we said when something reacts with cold water, it should give what? It should give the hydroxide and hydrogen, and then you need to balance. Remember that hydrogen is diatomic, it has to be H2, and then you need to balance, so we need to put 2 in front of the hydrogens in order to increase it, because this was 2 hydrogens before the arrow and 3 hydrogens after the arrow, so you put 2 hydrogens in front of the water. But that means that now you have 2 oxygens, so you need 2 of these, and then you have 2 rubidiums, so you put 2 here. Okay, brass is an alloy of copper and zinc. So just 2 reasons why brass is often used in preference of copper. Why do we use the alloy instead of the pure metal? We said because it is harder, more resistant to corrosion. So it is harder or stronger, and it is more resistant to corrosion. Sacrificial protection is a method of rust prevention. Explain in terms of electron transfer why steel, which is in electrical contact with zinc, does not rust. Remember we said when we touch or we join the zinc with the steel, why is it that the steel does not rust? Because zinc is more reactive than iron, so it loses electrons and becomes oxidized instead of the iron. Electrons are transferred from the zinc to the iron, so the iron cannot be oxidized or it cannot lose electrons. Okay, so just why the introduction of a different atom into the structure makes the alloy less malleable. Why is alloy less malleable than the pure metal? We said this is because atoms of different sizes do not allow the layers of positive ions to slide over each other. Okay, explain why overhead electrical power cables are made from aluminium with a steel core. So why aluminium? Why steel core? We said aluminium has low density, good conductor of electricity. Steel because it is hard and makes the cable strong. Reactive metals tend to have unreactive compounds. The following is part of the reactivity series. So sodium in that series is more reactive than silver, for example. Which of the metals in the list have oxides which are not reduced by carbon? Again, remember that where is carbon in the electrochemical series? Well, in this list here, it is above zinc. So carbon is more reactive than zinc, and we said if carbon is more reactive than zinc, then it will react with its oxide. But if it is less reactive than the metal, then it will not react with that metal's oxide. So which of the metals have oxides that cannot react with carbon? Well, it is the ones that will be above carbon. So that will be sodium and calcium, because carbon cannot displace sodium since it is less reactive than it. Choose from the list metal ions which would react with zinc. So zinc can react with what and displace it? Well, it has to be something that is below zinc in the reactivity series. So it will react with copper something or silver something and displace it, because zinc is more reactive than that. Okay, the following metals are in order of reactivity. For these metals which react with water or steam, name the products of the reaction, otherwise write no reaction. See potassium. Potassium is a very reactive metal. It's at the top of the reactivity series. So does it react with cold water or with steam? It reacts with cold water. And we said when something reacts with cold water, it forms the hydroxide and hydrogen. What about zinc? Zinc is in the middle of the reactivity series, so it is not that reactive. We said anything below magnesium in the reactivity series will react only with steam, and when it reacts with steam, it forms the oxide and hydrogen. Now, copper is below hydrogen in the electrochemical series, so it will not react with water or with steam or with acids if it's below hydrogen. Okay, explain the term malleable. We said, what do you mean by the metals are malleable? It means it can be spread into sheets. Why are metals malleable? We said, why are metals malleable? Because layers of positive ions can slide over each other when heated or hammered. All metal nitrates decompose when heated. A few form nitrite and oxygen. Most will form metal oxide, oxygen, and a brown gas called nitrogen dioxide. So which does which? We said which one will form nitrite and oxygen? We said the nitrates of group 1. Group 1 will form nitrite and oxygen. So when he says name a metal whose nitrate decomposes to form nitrite and oxygen, you can choose any metal from group 1. Now, any other group, the nitrate will form what? The nitrate will form the oxide and nitrogen dioxide and oxygen. And when you balance, you will find that you need to put 2 to 4, okay, in order to balance it. Suggest why the nitrate of the metal decomposes less readily than lead nitrate. So why is it that sodium nitrate, for example, does not decompose easily? Because sodium is more reactive, its nitrate has stronger ionic bonds and is more stable. Okay, sodium is a more reactive metal than lead, so its compound has stronger ionic bonds and will be more stable. Complete the following equations. Calcium carbonate. We said when we heat a carbonate of any metal except group 1, what do we get? We get the oxide plus carbon dioxide. What about if we heat calcium hydroxide? What should we get? Calcium hydroxide will give the oxide plus water, and these are balanced. Remember, if he gives you a symbol equation, it has to be balanced. So I check if it is balanced or not. Yes, then I can move on. All nitrates decompose when heated. The equation for the thermal decomposition of silver nitrate is this. Notice that this is an exception to what we said. This is different from what we said. But he's asking what are the products formed when copper nitrate is heated. Remember, when we said we heat the nitrate of anything that's not group 1, it gives what? It will give the oxide, nitrogen dioxide, and oxygen. So this will give copper 2 oxide, nitrogen dioxide, and oxygen. But when we heat sodium nitrate, we said what will be obtained if we heat nitrates of group 1? We said the nitrite plus oxygen, and you need to balance, and you will find that you will need this kind of balance. Okay, name a metal hydroxide which does not decompose when heated. Again, metal hydroxides that do not decompose have to be from group 1. So let's say, for example, sodium hydroxide. Now, if we have hydroxide of any other metal, like copper hydroxide, what happens when we heat it? It gives the oxide plus water. Again, I'm going to remind you, when he says write equation, he did not mention word. That means he doesn't want word. He wants the balanced chemical equation. So this is already balanced, so we can move on. So just why these two hydroxides behave differently? Again, why is it that sodium hydroxide does not break up? Because it is more stable with stronger ionic bonds. Metal nitrates, except those of group 1, form 3 products when heated. So name the products formed when zinc nitrate is heated. Again, when I heat zinc nitrate, what should it give me? The oxide, nitrogen dioxide, and oxygen gas. Write the equation for the thermal decomposition of potassium nitrate. Again, potassium nitrate is a nitrate of group 1. We said that will mean that when it breaks up, it will give the nitrite plus oxygen, and you balance the equation. Were you able to do all of this? If you studied the notes and you went over the video that explained it, you should be able to do these questions. Okay, a strip of magnesium ribbon was loosely coiled, placed in this crucible. Anyway, what he's saying is he heated it. Describe the appearance of the magnesium. We said at the beginning magnesium is a metal, so it is a silvery gray metal. But at the end, when it reacts with oxygen, it forms magnesium oxide. What is the appearance of magnesium oxide? We said that's a white solid or a white ash. Name the element that reacted with magnesium. Well, in order to burn, magnesium has to react with oxygen. And again, why was the lid lifted during heating? We said when we're doing this kind of reaction, we should lift the lid from time to time to allow air to enter. Suggest why the mass of the magnesium oxide was found to be lower. Usually when we do any experiment, usually what we get is much lower than what we expect. So in this experiment, if he says the mass of the magnesium oxide was found to be lower, why do you think we got less than we should? Well, some of the white solid formed was lost. Maybe when I removed the lid, some of it was lost, or not all the magnesium reacted. Okay. Reactivity series shows the metals in order of reactivity. So zinc is more reactive than lead. The reactivity series can be written as a list of ionic equations. So in the space at the top of the list, write an ionic equation for a metal which is more reactive than zinc. So you can choose anything. Which one is more reactive than zinc? Something like magnesium, for example. Now magnesium, if we react it, it gives 2 electrons and becomes magnesium 2+. Okay, if you choose something from group 1, then it will be only 1 positive and 1 electron. Write an equation, ionic equation, for the reaction between silver nitrate and zinc. Do you remember how to write ionic equations? This is the ionic equation where we have nitrates are common, found before and after the arrow, so we're going to cancel these. The zinc and the silver are solid, so you don't ionize them. I hope you remember how to write ionic equations. Okay, explain why the positive ions are likely to be oxidizing agents. We said oxidizing agents means they become reduced. Become reduced means they gain electrons. Well, potassium ions or positive ions, when they start to react, they would want to gain electrons. Deduce which ion is the best oxidizing agent. Which one is more likely to gain electrons? The one that is at the bottom of the series, the one that is less reactive as a metal. Because remember, when we say something is a reactive metal, it tends to lose electrons, not gain electrons. So the one that is more likely in the list to gain electrons is the one that is less reactive. Which ion in the list can oxidize lead? Well, oxidize lead means take electrons from lead, so it has to be something that is more likely to gain electrons, so one that is at the end of the reactivity series. State the use of mild steel, Carbonates, or machinery. Name and give use of another iron-containing alloy. Which one was the other iron-containing alloy? We said mild steel or stainless steel. Now, what do we use stainless steel for? We said either for chemical plants or for cutlery. Why are steel alloys used in preference to iron? Why do we prefer to use alloys? Because they are stronger and harder. Give one use of copper other than making alloys. What do we use copper for? We use it for electric wires. So just a reason why a bronze axe was better than a copper axe. So he's saying bronze is an alloy. So why is it better for an axe than the pure metal? Because bronze is stronger or harder. Brass is another copper alloy. Name the other metal in brass. Do you remember what was brass? Brass was what plus what? Copper and zinc. The diagram below shows the arrangement of particles in a pure metal. What is the name given to a regular arrangement of particles in a crystalline solid? Remember that this is called a lattice. This is called a crystal lattice. Draw a diagram which shows arrangement of particles in an alloy. What was the diagram for an alloy? We said you should show regular rows of a certain size of atoms with a few in between that are a different size, either bigger or smaller. Okay, let's just skip the whole introduction. He's saying complete the equation for thermal decomposition of copper hydroxide. Copper hydroxide, we said if we heat it, it gives what? Copper oxide and water. Choose a metal from the above series whose hydroxide does not decompose when heated. Remember, where is the series again? This is the series. The ones on top are more reactive than the ones down, and he wants something whose hydroxide does not decompose, so it has to be group 1. So which of this in this list is group 1? That is the rubidium, right? So that is rubidium. Remember that hydroxides of group 1 do not decompose when heated. Which metals in the series above do not react with acids to form hydrogen? Again, let's just go back again to the list. If it does not react with water or acid, then it must be below hydrogen. So we have here copper and mercury. Okay? Describe an experiment to confirm this prediction. The prediction says that copper and mercury will not react with acids. So which simple experiment can I do to show that they do not react with acids? Usually we add it to dilute hydrochloric acid. If it does not react, then no bubbles of gas are formed. Which metal in the series above can form a negative ion which gives a pink solution or a purple solution? Remember that in our syllabus we don't talk about anything purple except the potassium manganate, which contains the manganese ion, because manganese is a transition metal, so its compounds are colored, and the one that gives a purple color is potassium manganate. Describe what you would observe when zinc is added to this purple color. Remember, when we were talking about oxidizing agent, we said potassium manganate is an oxidizing agent. So when it reacts with something, that is a reducing agent, and when it reacts, it changes from purple to colors. Okay. Aluminium is used to make food containers because it resists corrosion. Explain why it's not attacked by acid. Why is it that aluminium does not react with acid, even though it's supposed to be a reactive metal, and it does not react with water, even though it's supposed to be a reactive metal? Remember that aluminium has a protective oxide layer. That's why it does not react. As a pure, clean metal, it should be a reactive metal, but because it usually has a thin layer of oxide which protects it from reaction, then it does not react, or it resists corrosion. Aluminium is used for overhead power cables, and we said give 2 properties of aluminium which make it suitable for overhead power cables. Why do we use it in overhead power cables? Because it's a good conductor of electricity and it has low density. Explain why we have a steel core. We said the steel core makes it stronger. You should remember all of this. Now, a method of preventing steel is sacrificial protection. Give an explanation in terms of electron transfer why the steel does not rust. We said we put a block of more reactive metal next to the steel. This prevents the steel from reacting. Why? Because magnesium is more reactive than iron, so it loses electrons, becomes oxidized instead of the iron. Now, another method of preventing steel rusting is cathodic protection. And he's saying, write an equation for the formation of the gas. In cathodic protection, we haven't studied cathodic protection, but he's explaining it to you, that instead of putting a more reactive metal next to the steel, it is connecting the less reactive metal, an inert anode, using a battery. So he's saying, write an equation for the formation of the gas giving off at the steel cathode. He already says it's bubbles of hydrogen gas, so you're supposed to write the equation for the formation of hydrogen gas. Now he's saying, give one difference between the two methods, between the previous method, which was sacrificial protection, and this method. So the difference between them is, in sacrificial protection, steel is connected to a more reactive metal. In cathodic protection, steel is connected to a less reactive metal. Another difference is that sacrificial protection has no power source, but cathodic protection has power source. Okay. In this question, he says the student investigated the reaction of air with copper. So he passed 100 centimeter cubed of air, continuously overheated copper. When the volume remained constant, the apparatus was left to cool. So if I pass air over copper, what is happening? The copper will react with the oxygen. So he's saying, first of all, complete the box to show the apparatus labeled. What's the name of that apparatus? It's a gas syringe. Indicate on the diagram with an arrow where heat is applied. Where are we going to heat? We're going to heat the copper. Okay. What should be used to transfer the copper from a bottle to the apparatus? Copper is a solid. To transfer a solid from the bottle to the apparatus, we use a spatula. The copper changed color from brown. We know that copper originally is brown or reddish brown, or sometimes we say it's red. To what? It's going to change into copper oxide. What is the color of copper oxide? Black. Why was the apparatus left to cool before measuring the final volume of gas? He says when the volume remained constant. Okay. Apparatus was left to cool and the volume of gas was measured. Of course, we need to leave it to cool because gases expand on heating. So we need to leave it to return back to the original room temperature so that we can compare it correctly. Okay, this is an experiment where he is reacting dilute hydrochloric acid with copper sulfate, aqueous copper sulfate. Okay, students investigate what happened when dilute hydrochloric acid and aqueous copper sulfate reacted with different metals. So he's putting 10 centimeter cubed of hydrochloric acid, 1 gram of zinc powder, and then he measured the maximum temperature. And then in experiment 2, he put 1 gram of iron with the hydrochloric acid and measured the temperature. Now in experiment 3, he put 1 gram of magnesium with the hydrochloric acid and measured the temperature. And he gives me temperatures, initial temperature, maximum temperature, and temperature rise. You know how to read a thermometer, right? So the initial temperature is 23 in the first one. It went up to 26, so the temperature rises the difference between them, so that is 3 degrees centigrade. Remember again, when you're filling out a table like this, you do not put the units inside the table because already the unit is at the top. So you don't write 23 degrees Celsius, 26 degrees Celsius. No, the unit is already at the top. Here, this is starting at 22, ending at 24, so the difference is 2. This starts at 21, ends at 71, so the difference is 50. Now in experiment 4, he put 10 centimeter cubed of copper sulfate, 1 gram of magnesium. And he's saying the gas was tested with a lighted splint and a loud pop was observed, and then they measured the maximum temperature. In experiment 5, he put iron instead of magnesium. So he put iron on the what again? I'm sorry, I'm going back again, on the copper sulfate. Okay, so he's putting copper sulfate and magnesium in experiment 4. Here it's copper sulfate and iron. A red-brown solid was formed. Now use the temperatures to complete the table. So experiment 4 started with 19. It ended up with 44. So the temperature rise is the difference between them. Experiment 5 started 21 and it went up to 29. So the temperature rise is the difference. Now he's saying we should draw what? We should draw a bar chart. You know how to draw a bar chart, do you? Okay. So first of all, rules for drawing a graph, we should first label the axis. So he already labeled the y-axis, but you should realize that the x-axis will be labeled experiment, because I'm going to put experiment 1, 2, 3, 4, 5. These are bars that are not touching, so they should be of equal thickness and equal differences between them. And then we look at the numbers of the temperature rise, and we find that the highest is 50. So we draw this, and we draw the bars for each of them from the readings that we had. So you should have something that looks like this. Okay, use the results and observations to answer the following question. Which experiment produced the largest temperature rise? So you find that one of them produced 50 degrees temperature rise, so that was experiment 3. Now when he says suggest why this experiment produced the largest temperature rise, what we will do is we will go back to the experiment and see what it was using. We will find that it was using magnesium instead of zinc and iron. So if it gave the largest temperature rise, then the magnesium is more reactive than zinc and iron. That is why it gave a higher temperature rise. Now name the gas given off in experiment 4. If you remember, he said in experiment 4 the gas when tested with a lighter splint, it pops. Which gas is tested with a lighter splint and pops? That is hydrogen. Now identify the reddish-brown solid formed. Of course, when we have a reddish-brown solid formed from something that starts with copper sulfate, then we're ending with copper. What type of chemical reaction occurs when iron reacts with copper sulfate? Remember we said a more reactive metal will displace a less reactive metal from its salt. So when iron reacts with copper sulfate, it displaces the copper sulfate, so this is a displacement reaction. Predict the effect on the temperature change if 1 gram of magnesium ribbon was used in experiment 3. Now, he used magnesium powder, so if I use magnesium ribbon, you should know that the ribbon is something that will make the reaction slower, so that will give a lower temperature rise. Why? Because the ribbon is a big piece while he used powder, so the big piece has less surface area, so less collisions. Now suggest why potassium was not used. We never use potassium in any of these experiments because potassium is very reactive. It is too reactive actually, so the reaction may be explosive. Okay. This is an experiment where he says 2 metals A and B react with dilute sulfuric acid to produce hydrogen, and we want to know which metal is the more reactive. So when we're trying to compare 2 metals and see which one is more reactive, we can put it in a flask connected to a gas syringe, and we should be able to measure how much gas is collected from each of them, and the one that gives more gas in the same time is more reactive. That means in order to compare between the 2 metals, the first thing we should do is weigh. So let us say, I usually explain for one and then say repeat with the other. So weigh 5 grams of the first metal, which is A, using, and you mention which apparatus you use, using a balance. Put into a flask connected to a gas syringe at 20, be specific, 20 centimeter cubed, or it doesn't matter 20 or 25, but just be specific. Add 20 centimeter cubed of dilute sulfuric acid to the flask using a dropping funnel. Remember, this is better so that you don't lose any gas from the experiment. Determine the volume of gas collected in 1 minute. So this is what we're measuring. What are we measuring? The volume of gas in 1 minute. And then I'm going to repeat using the same mass of the other metal and the same volume of sulfuric acid. The one that forms more gas in 1 minute is more reactive. Okay? This is an experiment to say, okay, solutions of chemicals known as corrosion inhibitors are added to water in steel radiators to reduce rust. You are provided with 3 different bottles of corrosion inhibitors, R, S, and T, and some steel nails. And you're supposed to plan an experiment to test if these inhibitors prevent the corrosion of steel and which of these inhibitors is the more. So basically we want to see which one doesn't rust or which one rusts less. Remember we said in order to know whether something, whether a piece of iron nail, for example, or a steel nail rusted more or less, this is seen from the mass, the change in mass. So if we leave the nails and the mass increases a lot, that means it has rusted a lot. If it doesn't increase a lot, that means it hasn't rusted. So basically we're trying to compare 3 solutions, R, S, and T, and some steel nails. So what are we going to do? Basically we need to get, for example, 3 test tubes, put equal amounts R, S, and T, and remember that he says in the first sentence, he says some of the chemicals known as corrosion inhibitors are added to water. So you need to add some water. So each of these test tubes contain water and R, for example, and then water and S, and so on. And we need to put the nails, but in order to determine which one has rusted more or less, then we need to weigh everything first. So we weigh each nail using a balance, put into different test tubes, put a specific amount, for example 20 centimeter cubed of water and 10 centimeter cubed of one of the inhibitors into each test tubes, and leave at room temperature. Usually the experiments for rust we leave for about 5 days, and we're mentioning at room temperature to show that they are at the same temperature. Okay, remove the nails and we leave them for about 5 days. Remove the nails, place into separate beakers, dry in an oven. Remember we said when we need to dry metals, we dry them in an oven. Weigh the nails. Now this question is asking for which is the better inhibitor. So the one with less increase in mass is the better inhibitor. But in other questions like this one, he will say, okay, iron rusts when in contact with air and water. You're provided with nails and 3 different samples of water: tap water, seawater, distilled water. Here he wants you to plan an investigation to find out which sample of water causes iron to rust the fastest. So this is basically the same thing, but you're putting different types of water and you want to know which one has rusted more, so which one has more increase in mass. So basically we're doing the same thing. Weigh the iron nails separately using balance, put into different test tubes, add 20 centimeter cubed of one of the samples of water to each test tube, leave at room temperature for the 5 days. This indicates that you're leaving them at the same temperature for the same time, for the same amount of time. Remove the nails, put into separate beakers, dry in an oven, weigh the one with what. So you tailor your answer according to the question. The other one was asking which inhibitor is better, so we said the one with less increase in mass. This one is the one with more increase in mass, has rusted more. Remember that in these kinds of questions it is always a good idea to draw in order to illustrate what we are explaining, and it is important because if your explanation is missing something, then maybe the diagram will allow you to get the grade for it. Okay, so we finished metals. Please study all of this and you should do a quiz on all of this.